Hi, in this video I'm going to show you how to find the derivatives of the Arcus functions arcsine, arccosine and arctangent, also known as the inverse trigonometric functions of sine, cosine and tangent. First, I'm going to do a quick informal derivation of the general method of finding derivatives of inverse functions. Let's suppose we have an invertible function f. For notational convenience, we let y be equal to the inverse function of f. So f minus 1 of x. Then, from the definition of the inverse function, we know that f evaluated at y is equal to x. Let's then take the derivative of both sides of the equation with respect to x. On the left-hand side, we need to use the chain rule. We get that it's equal to the derivative of the inner function with respect to x, dy dx, times the derivative of the outer function with respect to x, df dx, evaluated at the value of the inner function. So evaluated at x is equal to y, and on the right hand side we're left with 1. Let's then divide both sides of the equation with this derivative to get that dy dx is equal to 1 over df dx evaluated at x is equal to y. And as we said at the beginning, y was our inverse function f minus 1 of x. So this here is the general method of finding derivatives of inverse functions. Let's then apply this to our Arcus functions. We get that the derivative of arcsine of x with respect to x is equal to 1 over the derivative of sine, so cosine, evaluated at the value of the inverse function, so arcsine of x. Then the derivative of arc cosine of x with respect to x is equal to 1 over the derivative of cosine with respect to x, which is minus sine of x, but evaluated at arc cosine of x. And lastly, the derivative of arctangent with respect to x, which is equal to 1 over cosine squared of x, evaluated at arctangent of x, but 1 over cosine squared is just cosine squared, and evaluated at arc tangent of x. Now our goal then becomes to simplify these expressions. We're going to do the simplification by considering the trigonometric identity cosine squared of x plus sine squared of x is equal to 1. We can take the sine squared of x to the right hand side to get that cosine squared of x is equal to 1 minus sine squared of x. We could take cosine squared of x to the right hand side to get that sine squared of x is equal to 1 minus cosine squared of x. And we can divide both sides of the equation by cosine squared of x to get that 1 plus sine squared of x divided by cosine squared of x is just tangent squared of x from the definition of the tangent. And this is equal to 1 over cosine squared of x. Let's then take the square root of the first two equations to get that cosine of x is equal to the square root of 1 minus sine squared of x. and sine of x is equal to the square root of 1 minus cosine squared of x. And let's invert the last equation to get that. Cosine squared of x is equal to 1 over 1 plus tangent squared of x. But we need to be a bit more careful here, since when we took the square root of the first two equations, we're allowed to consider only the positive square root when the thing we're squaring here is non-negative. So these first two equations only hold true when in the first equation cosine of x is greater than or equal to 0, and in the second equation sine of x is greater than or equal to 0. And in the last equation we should have been a bit more careful, since when we divide it by cosine squared of x, we need to be sure that cosine squared of x is not equal to 0 and cosine squared of x is equal to 0 when cosine of x is 0 and cosine of x is 0 when x is pi over 2 plus some multiple of pi. So we need to require that in the last equation x is not equal to pi over 2 plus some multiple of pi. Now let's see if we can apply these equations to simplify this expression. Let's start with the derivative of arcsin of x. We know that cosine of x is non-negative on the interval from minus pi over 2 to pi over 2. But the range of arcsin of x is from minus pi over 2 to pi over 2, so we're justified in using this expression to simplify. So we get that we can replace cosine with the square root of 1 minus sine squared, 1 minus sine squared, but here evaluated at arcsin of x. Now just from the definition of the inverse functions, we know that sine at arcsin of x is just x, so we're left with 1 over the square root of 1 minus x squared. Now let's consider the derivative of arccosine of x. We know that sine is non-negative on the interval from minus pi to pi, but the range of arccosine of x is from minus pi to pi, so we're justified in using this equation to simplify. So we get this equal to 1 over the square root of 1 minus cosine squared of arccosine of x. And cosine at arccosine of x is just x. So we're left with minus 1 over the square root of 1 minus x squared. And lastly, let's consider the derivative of arctangent of x. The range of arctangent of x is the open interval from minus pi over 2 to pi over 2, so its value is never pi over 2 plus some multiple of pi, so we're justified in using this equation to simplify. So we get that it's equal to 1 over 1 plus tangent squared evaluated at arc tangent of x, and tangent at arctangent of x is just x, so this is equal to 1 over 1 plus x squared, and these here are our final solutions.